So we described uniform circular motion as motion that is uniform, meaning at a constant speed, and circular, meaning that your object is moving along some circle. And so the thing that we want to emphasize here is that your velocity vector, in order for that to happen, its magnitude doesn't change, because that's what constant speed means, right? The magnitude of the velocity vector is going to stay the same if your object's traveling at a constant speed, but its direction will, because the velocity vector will always point tangent to the circle. As your object moves along the circle, the velocity vector changes its direction. Well, of course, if you change the velocity vector in any way, there has to be an acceleration. So here our object isn't speeding up or slowing down, but because it's changing direction, we still need an acceleration. So even though our object is moving at a constant speed, there's an acceleration that keeps the object moving along a circular path. The name we give to that acceleration is the centripetal acceleration. So the centripetal acceleration is the acceleration that's going to hold your object on the circular path as it travels with a constant speed. And so like any vector, we can talk about both its magnitude and its direction. So in terms of its magnitude, the magnitude of the centripetal acceleration you can calculate by v squared over r. So the speed your object's moving at squared divided by the radius of the circle. For uniform circular motion, where the speed is constant, that means the magnitude of the centripetal acceleration is constant. It doesn't change because the speed doesn't change and you don't change the radius of your circle. The direction of the centripetal acceleration always points towards the center of the circle. So what this means is that if you can figure out where the center of the circle is, then you can always figure out the direction of the centripetal acceleration. How we're going to use this is that, again, centripetal acceleration problems are simply going to be a variation on Newton's second law. The difference is that instead of using speeding up or slowing down to figure out the direction of the acceleration, our objects are going to move with a constant speed, but because they move along a circle, we're going to still be able to figure out the direction of the acceleration because we know that it always has to point back towards the circle's center. We're going to work our centripetal acceleration problems as Newton's second law problems. They're just Newton's second law problems where we have a different rule for figuring out the direction of the acceleration, and then we have a magnitude that we're going to be able to plug in, v squared over r, to calculate what the magnitude of the acceleration is.